Okay, so first things first. We are now getting to the point where we have a fair amount of code. I guess honestly, it's not too much, but it's containing a few different things, right? Like we have these functions here, which are dealing with strings. We have these functions here, which are dealing like with position vectors. And we have this main function, which is doing all of our game logic. And then I also have a bunch of notes up here, which is, just things I've been jotting down about how I think the game might work or ideas I want to try and show off. So, given that, I'm going to go ahead and make a directory where I can move the game and start keeping all the files in there and maybe even have multiple files. So, I'm going to do make dir. So I'll call this text game, and then I can go ahead and move ASCII game into text game. We can just call this let's call this game.c, right? So if I go in here, I look at game.c, we see we have everything. Go ahead and expand that. All right, so I'm going to go ahead and open up a new file. I'll just call this notes, and then I can go ahead and copy all of these things over into there. So yeah, that was like 80 lines of notes that we don't need, cluttering up our code. And then we can just go ahead and keep this one file the same for now. We'll probably split it up into in fact, we'll definitely split it up into multiple files in a little bit. But for right now, I think this is okay. So now that we have that, in fact, I can go into our text game right here, and I can run this, and now we should get the exact same thing as before, which we do. All right, so what I want to do is a couple of things. So given the fact that this is a typing game, or something like a typing game, again, I don't know exactly what this game is going to be like. This is part of the goal is to show off the process of figuring that stuff out. But I think it would probably be more interesting to have entities or like characters, creatures, things like that in the game be comprised of multiple characters rather than just a single character. So, in a traditional roguelike game, you would have, a W, which would just stand for wolf, and then you have like a lowercase w, which would maybe be like a wolf puppy, and then you have, I don't know, a capital T for a tree, and then a lowercase t for a cup of tea, and, things like that, right? So, what I want to go ahead and actually do, though, is display words for the entities in the game. So, the way I think I'm going to start doing that is, well, let's see, there's probably a couple ways. So we can just talk about what would make the most sense. So right now, our draw level function, despite all its problems of, having to take these different things and, maybe not being very flexible in that way, we need a way to go ahead and print multiple characters for a single thing, probably. What we could actually do, and I think this is probably better, is we can just go ahead and say, so, if we want, I just draw a little diagram right here, or type one out. So what we want is to have, like, the player right here. I'll draw the border. like that, and then we would have the border that goes all around there. And we would like something like that, right? To be how we draw an entity in the game, right? So what I think we will want for that is to compose um, that wolf out of multiple renderable characters, right? So since we are just going ahead and rendering one thing at a time, right? Because we're just looping over each grid position, right? And then we're going to draw something. What I would like to do is go ahead and sort of break that out. So we have this struct. We will call this renderable glyph, right? So, and a glyph is just, it's another name that comes from typography for a character or a letter. Usually we think of a letter as being, A through Z, right? But an equal sign isn't a letter. So, it's a glyph, right? It comes from typography where you would have the little piece of metal, and then you would, dip that piece of metal in ink and then put it on a paper, and that would be the symbol. So this is going to have a position. It's going to have a symbol. And that's really the only two things it needs, right? So the way that this would work is we would say that if we have a creature, right, like a wolf, a creature would be composed of multiple renderable glyphs, right? It would have several of these together, and then when we're drawing it, we're just trying to figure out where those glyphs are, right? So what we can do then is say renderable glyph like that. So we're just going to kind of be replacing things in place. This is a fairly common, programming pattern or a refactoring that you would see, especially in game development, where you have this new feature that you want to implement or sort of re-architect the way that the code works. But you don't want to just go ahead and rip out all of the old code. So you want the game to still be functional and still work. So you kind of, do the scaffolding as you go along. So you pick one very small subset of the features that you want to rewrite, and then you get that working with the new system. And you sort of expand off of that, right? So I'm going to go ahead and keep symbol around for right now, just so none of the code breaks. But I'm going to introduce this idea of a glyph and try to get it so that we start using the glyphs for it to work, right? So what we actually want, though, is we want to have multiple glyphs, right? So we want an array of them. And we can do that by going ahead and making a pointer to a bunch of glyphs. So this creature is going to have a pointer to a bunch of glyphs. And then we can see how we're going to figure out what it is pointing to, right? And, for the player, I think it's safe to say, at least for right now, that we're just going to have a single glyph, right? I mean, in all honesty, we aren't even using anything different for the player, so maybe we don't even care about that, honestly. We won't even bother replacing that for the player right now. Maybe in the future we'll care about that, but we don't right now. So, what we need to do right here is we're just going to make a note and say to do see if this position in the grid is the position of any of the glyphs that were passed in. So now we have this situation where we aren't just going to be checking one single thing, right? We aren't just going to be checking the creature's position. We are going to be checking the position of all of these different glyphs and where they are and where to draw them, right? So let's go ahead and get that set up first. So we have this creature right here, and what I'm going to do is say creature.glyphs equals, something, right? Not super elegant code. Now, the way that this is going to work is we have a pointer to some number of glyphs, right? But we haven't said how many, which is different than when we've made the arrays, right? Because when we made input, we said, okay, hey, there are 256 characters in this array, and we're going to pass it around like a pointer. We're going to give the address of where the input is stored. But we know where it's stored. It's stored inside of this thing input, and we know, how big it is, right? But here, what we want to do is get some memory from the computer. We want to tell it how much memory. And then we want to go ahead and say that we are now going to be pointing to wherever that memory was allocated. So that is where this function comes in, which is known as malloc. It stands for make allocation. And so what this is going to do is tell the operating system, hey, I'm going to need some number of bytes, and I want you to give me, I want you to reserve those number of bytes for me, and I want you to give me the address of where you started storing them. We can go ahead and look at that. If we look at man malloc, we get this very long thing. So you see it's in standard lib, which is why I included that at the beginning a few videos ago. And all this takes is a size, right? And we can see, this is actually kind of a long description compared to what we saw for memset earlier. But it allocates size bytes and returns a pointer to the allocated memory. The memory is not initialized. Now, what that means by the memory is not initialized is, remember, we had this thing where we did the memset earlier, where we want to say, hey, I want you to take all of this memory, and I want you to go ahead and set it to be 0, right? So that initializes it to something. And if the size is 0, then it returns null. Which, again, that's not really a concern for us because we aren't going to be asking for null things. So in this case, I know that I want 4 glyphs, right? Because I want a glyph for each letter, which means I'm going to want wolf, right? So what we can do is say we're going to have 4. But, of course, this is, bytes, right? So we want to know how many bytes a glyph is. Well, luckily for us, we have this size of, and this is going to be renderable glyph, right? And then that is going to return us, you see, a void star. Now, this is something we haven't seen with pointers yet. So the void star just means it's an address. It doesn't know anything about the type of thing that's stored at that address. Because, again, malloc, it's very dumb, right? All it's going to do is give us memory. It's going to give us memory of some bytes, right? But we want our glyphs, we want that pointer to know, hey, this isn't just some random number of bytes. This is a renderable glyph, right? That's what we're storing right here. So we can do what's known as a cast, where I will cast it to this. So I will take the void star, which is an address, and I will cast it to a renderable glyph address. Now, keep in mind, this is the exact same address that we get. It's the same numbers. The memory is stored in the same location, but we know Now, what type of memory is being stored there? Which means when we do things like, let's say, creature.glyphs, like this, right, of 0, we know, all right, hey, I don't want just the 0th byte or the first byte or the second byte, etc. I know that I want to move some number of bytes by whatever the size of a renderable glyph is. I believe in our case, a renderable glyph should be 12 bytes, right? Because it's going to be 4 bytes for the X position, 4 bytes for the Y. Oh, sorry, it's going to be 9 bytes. And yeah, 1 byte for the character. So we can go ahead and make sure that that compiles. Okay, so because I think I called this, yeah, we went glyphs, right? A nice name to indicate that we have multiple of them. Renderable glyph, probably because I spelled it wrong. Let's see, renderable glyph. I did not seem to spell it wrong. Oh, yeah, because, I forgot that. Okay, assignment from incompatible types. It is incompatible pointer types. Oh, yeah, so this is a warning. And then right here, up here, we want to say struct renderable glyphs. That might be, yeah, that was the only reason it was giving us the warning. So yeah, I do a lot of programming in C++ where you don't have to type the struct every time, so I'm not used to it, or not that used to it. All right, so now we're in the same situation as before, right? Which is perfect. So now let's just go ahead and say that we have one of those, right? And we're gonna say this. We are going to say that its position dot position equals creature dot position, like that, and then creature dot glyphs of 0 dot c equals w. And we can go ahead and set this up for a couple others. Like that, right? And what we're going to want to do is say for these, right? We want to go ahead and say that the creature.glyphs1.position.x plus equals 1, right? And then we're going to do plus equals 2 and plus equals 3, right? So that the position of the character is always going to be, 1 over successively, or successively from the initial position. Let's go ahead and compile that. Yeah, because it's not .c, it's .c. Well, you know what? I'm going to change it to .c. Like, symbol is kind of, a meaningless thing. We might as well just use C. All right, so now that we have this, what we can do is just look up creature.glyphs of 0.c, right? So we should get the same thing, right? And, if I try doing that with 1, then we get the, oh, okay, cool. But what I actually want to do is this. So the issue is that we don't necessarily know how many glyphs we have for this creature. Now, I mean, technically we do as humans because we went ahead and said that, oh, hey, we had 4, right? But we aren't storing that information anywhere. So just when we pass in a creature to something, we don't have a way in that code to look up how many characters or how many glyphs it has, right? So something that I think would be nice to do is go ahead and we'll do int glyph count, right? Like that. And of course, we're still working because we aren't doing anything with it. But now what I want to do is say, all right, else. So we know it isn't the player. So now we need to do check to see if it's a creature. And then if it isn't a creature, draw a space, right? So we are going to do this loop where we're going to say int I equals 0, I is less than creature dot glyph count I plus plus. And now we're going to say right here, so we're going to check for each of the glyphs in the creature, right? We're going to say, all right, hey, if equal creature dot glyphs of I dot position, if that equals the position of where we're trying to draw, then we're going to do this, right? And I'll make sure to change it to an I so that way we draw the correct one. And I'm going to say right here, I'm going to say found glyph equals false. And I'm going to say, hey, if we ever found a glyph, we're going to set that equal to true. We're going to break out of our for loop. And then right here, I'm going to say if we didn't find a glyph, I'm going to go ahead and print this space, right? So you see the structure of our rendering code changed pretty substantially, right? So we wound up, taking this if, else, else, and we wound up breaking it into an else right here, which has this, the case where we're drawing a space in like that. See, it's going to be creature, creature. Okay, cool. And now we're drawing the wolf. Neato. So yeah, that is pretty neat. There's some definite ways that this could change to be improved. So one thing that could be a definite issue is that we are specifying the position of all of these glyphs in what's known as global space, right? So you can think of space. In this case, we have a 2D grid, right? So global space is just that we have 0, 0, 0, 1, 0, 2, etc. And it's just specifying things where they are in the world, right? And that's always relative to the origin. So if the origin is at 0, 0, then something at 0, 1 means it's 1 above the origin. If it's at 1, 1, that means it's 1 to the right and 1 above the origin, etc. But we could also have what's known as local positioning, right? Where you have a position relative to something else in the world. So, for instance, right now, the player, when they start, is at 5, 5, right? And if we had something relative to the player at, say, 0, 1, that would mean that they are 1 above the player, which means that their world coordinates would be 5, 6, right? So we can see in this case where we have, multiple letters making up a single thing in the world, right? In this case, a creature, right? Well, it's kind of weird that we have to specify the parts of that creature in world positions, right? Maybe it's not that big of a deal, but it just might be something to think about, right? Keep it in the back of your mind, because when we start moving this wolf, like we are about to, we run into an issue where, okay, every time we move the creature, we also have to move all of the glyphs, right? So that could start to be an issue for us. So let's go ahead and run that right now. So I'm going to make a function that's going to be called, I don't know, update wolf position, right? Or in fact, I don't even care. It's just update creature position, right? And so we are going to pass in a struct creature, and we're going to pass it in as a pointer, right? And we'll see why in just a second. And then let's also go ahead and pass in the player, right? So it makes sense because, oftentimes creatures, they're going to be reacting to the player, right? So maybe we want to know where the player is in the world. All right, so the creature is passed in as a pointer because what we want to do is take the position stored in the creature, and we want to change that position to make it closer to the player. So this is very much like our square function right here that took a pointer, right? Where here it might seem kind of, ridiculous. Like, why don't we just say that x equals the thing, right? Whereas here, it's maybe a little nicer that we can just call an update creature rather than saying, position, new position equals update creature position, right? With a creature and a player. And then we can say creature dot position equals new position, right? So this is, this is maybe just not as elegant or as just easy to reason about. This thing just taking a pointer and changing the position of the thing that's stored there, right? So what we can do is go ahead and right here we just say that every turn we are going to update the creature position. In fact, we'll do if creature.health is greater than 0, then we'll update it, right? Go ahead and pass in the creature, and then we will go ahead and I'm actually going to do this right here. I'm going to do this before we draw the world. I'm going to update the creature, and then we're going to pass in the player, right? So what I want to do is say that we have 2 points in space, right? And we want to know what the difference between those points are. We want to know essentially the direction that is between these entities, right? And then I want to go ahead and say that the creature moves 1 unit in that direction, right? So if the player's right above, then the creature is going to move 1 unit up. If the player is, 5 units to the right, then the creature is going to move 1 unit to the right. So the nicest way to do that is to have this thing, which is going to return us a position. We'll go ahead and call it sub for subtraction. And position B, right? Now we are going to make a new position, which is our result. And then we are going to say that result.x equals position A.x minus position B.x, and result.y equals position A.y minus position B.y. And then we are going to return the result, right? And while I'm at it, I can just go ahead and make one of those for add also. And, we'll even do, for add, we can do multiply. And then we can do mult divide like that, right? And, I'm going to add these, well, no, I don't think that matters. I was going to say maybe I was going to name it like subtract position, add position, etc. But I don't think we're going to really have other functions we need to be calling subtract and add and multiply and divide. So I think we're fine on that front. Maybe I'll change my mind later. We'll see. So what this is going to do is say we're going to have a position, and we're going to call this diff, and that's going to be equal to creature.position and then player.position. And we can go ahead and compile this and see the error that we get. So this is saying, hey, creature is a pointer. Did you mean to use arrow, this arrow symbol? And you might be thinking, I haven't seen that. And you're right, you haven't. So when we have a pointer to a struct, normally we go ahead and access the elements of a struct by using this dot operator, this period. When it's a pointer, though, we go ahead and use an arrow symbol. I don't know exactly why. It seems like, maybe it helps readability, right? Maybe it just helps you whenever you see an arrow sign. You're like, oh, hey, I know this is a pointer. Good thing to know. Because, anytime you see a pointer, then you know that maybe, anytime it's a pointer, you know that something in it could be changing, right? So we know that this update creature position is changing something in the creature because it's a pointer. Whereas if we just passed in the creature, we might say that, it's only going to return us some value, right? We just, we aren't modifying anything. Like our sub function, we know, hey, it's not changing the creature's position. It's not changing the player's position. It's just giving us a new position, which can be nice to know. So maybe that's the reason behind the arrow. I've never really looked into it. Just anytime you have a pointer to a struct, use an arrow. Now, what I want to do is get a position, which is a direction. And maybe we don't know exactly how to do that. So the issue is that I only want the wolf to move in one unit at a time, right? I don't want the wolf to say, oh, hey, I'm going to attack the player, and the player is 5 units away. Well, I'll just lunge at them immediately and start beating up on them, right? If you're far enough away from the wolf, you should be able to just run, probably. So what we want to do is go ahead and convert this difference, right, into a direction, which is just going to be normalized. So by normalized, and this is a technical math term, so this isn't going to be necessarily the exact definition in our case, but normalized means that everything is in the range from 0 to 1, right? Now, since we're dealing with whole numbers, that's not an issue for us. Well, sorry, I guess in this case, normalized is going to be from -1 to 1, right? Because we'll need to know if something is left or below, right? So we want to go ahead and convert something. So if we get a vector that says, hey, 5, 0, right? If we have, or a position that's 5, 0, if that's the difference, then we know that the player is 5 units to the right, But we want to go ahead and say, hey, you know what? That is really just 1 unit to the right. That's no big deal, right? If it's -5 units, then we know it's 5 units to the left, right? In which case we just want to say, hey, the direction is -1, which means that we can just go ahead and say, hey, take the difference, give me the direction, and then move 1 unit in that direction, right? And since the direction is already in terms of 1 unit, it's very nice. So I'm going to go ahead and write a new function, which is going, I guess, to be called dir. And this is going to take a position like that. And then we'll have a result, and we'll return the result. And what we're going to do is say that if position.x, well, I guess first we'll say result.x equals 0, and then result.y equals 0. We'll say, hey, if position.x is greater than 0, then result.x equals 1. Else, if position.x is less than 0, result.x equals -1, right? And then we'll do exactly the same things for y. So we see that, if we pass in a position that's 0, 0, then we're just going to get a direction of 0, right? And this just lets us very nicely go ahead and I don't want to pass in creature position. I want to pass in the diff, right? So I go ahead and delete that, and then I can just say, all right, creature position equals. We'll go ahead and we'll add the current creature position and the direction, right? So if we have a position at 5, 5, and our direction, we have a position at 5, 5, and our diff is 5, 0, then we know that the thing is at position 10, 5. And we want to know that our direction is just 1, so we're going to be moving 1 to the right. And then we just want to add that position to our creature position, right? So we can go ahead and do that. And looks like we are not actually updating things correctly. So let's go ahead and put a printf in. We can say that the diff is that, say creature position.x, diff.x, diff.y, and we can do the same thing for the direction. And I keep forgetting to do these new lines. Do dir for that, right? Okay. Oh yeah, I see why. This is exactly why I had mentioned that relative position thing before. So we are changing the position of the creature, but we are not changing the position of all of the glyphs, right? So what we actually want to do right here, maybe, and this is probably bad, but we can go ahead and change it later. We'll do creature, glyph count, I++. We'll say that, hey, the creature, the creature glyphs of I dot position equals add of creature glyphs I dot position and direction, right? So now we're taking all of the glyphs that make up a creature and we are adding one to their position. So something at least happened. Maybe it's not correct. Let's see here. Just go ahead and make one move to the right. So now the diff is -1, 3, which makes it seem like the creature... Let's see, wait. Let me just check real quick our rendering code. So if it's the original difference is -1, 3, that means, yeah, so we move 1, so now over 1 more. We are above. If I go ahead and run it like this. I'm going to try saying that our creature is going to start at, I don't know, y equals 2. This might be a problem with the y position. Yeah, so, yeah, I think that is the issue. So, if we go ahead and let's start moving down, well, it looks like we're always moving. If I move down, the wolf is moving up. But if I move up, the wolf should not also be moving up. So that tells me that there's a problem. The direction seems to always be -1. We have a problem right here. It's greater than 0. Else if it's less than 0. That seems like it should certainly be working. I'm just making sure we aren't doing anything like subtracting A from A or something like that. What if, right here, I just go ahead and say that we're just going to do this, where we're just going to say, hey, all of the letters always equals the creature's position, right? So this way, we don't have to worry about multiple glyphs. We can just see what's going on with one, right? And it looks like that isn't really making it any clearer, but at least we know that the issue is sort of general. It isn't just with our one case, right? All right, so yeah, okay. So the weird thing is that the difference should not be -0 and -2. 0 seems fine, right? But if this is if the wolf is starting at 2 and the player is starting at 5, the difference should be 5, or it should be 3, not -2. So yeah, this is just a simple math problem. We want to be taking the player's position minus the creature's position, and that's going to go ahead and give us the direction, or at least that should be a start. So now you can see the creature is following me. If I start moving to the right, and you know, it's always just staying on me now, right? Okay, cool. So we can go ahead and delete that, and then we should go ahead and get the same thing here. So if I move down, yeah, it keeps following me. Oh no, I'm going to get eaten. This doesn't look good. Oh no, it smells like golf or something. And it's just always going to stay with me, right? And now I'm off the screen, so it's gone. So this is, our first example of maybe artificial intelligence. It's not great intelligence. It's not even very smart for a wolf, but it is something at least. So I think that'll do it for this video. Again, one of the main takeaways is this thing Malloc right here. We'll see a lot more of this in the future. This is kind of one of the things that gets to the heart of why you program in C, is we can do something as powerful as ask the computer for a specific number of bytes and find out where those bytes are stored, right? Which is very important when you want to write applications that run quickly. And we'll see more of that in the future, but this is just a very cool, powerful, advanced feature of a programming language, and we get to use it and play around with it, which is great fun.